Hello and welcome to CSIT 301 Mobile Application Development, Session 5, Part 2. In this session, we'll be looking at the client-side development, specifically focusing on local storage APIs. Most of the time, developers crave for a mechanism for storing the repeated and the most sensitive part on the client-side application. Now, because of this desire, Worklight has a mechanism that cuts across all supported platforms such as Android, iOS, and Windows. This session provides a detailed look at the encrypted cache and the JSONStore local storage APIs provided by Worklight. At the end of this session, every student should be able to identify the Worklight client-side APIs that supports storing data locally on a device in an encrypted cache or a JSONStore data. Be able to explore the syntax of JavaScript functions that support the API. The key topics for today would be encrypted cache, JSON data store, JSONStore architecture, JSONStore advanced features, and finally we'll look at pushing and pulling data with JSONStore. The reading lists have been uploaded onto the Sakai. Please do well to use them. Now, encrypted cache is a mechanism for storing sensitive data on the client side. Now, its implementation is done by using the HTML5 local storage technology. This allows data to be saved locally and retrieved on subsequent application use or relaunch. Now, the data in the encrypted cache is stored with key value pairs. Encrypted cache is just like a security deposit box. It remains open until closed. So it's also important to close the cache once you are done working with it. The browsers that support encrypted cache are displayed. For Internet Explorer, anyone greater than version 9 or 9 are supported. The IE Mobile, that's the Internet Explorer Mobile, from version 10 upwards are supported. With the Firefox version 26, 27 and upwards are supported. For Safari, we can see version 5, 6, 7, 5.1, 6.1 all supported. And on the Android device, we have from Android version 4.2 and upwards. Same for BlackBerry, where we have 7.0 and 10.0. Now, this means that if you use an encrypted cache on an application which is deployed on a mobile application which doesn't match or isn't greater than these versions, it wouldn't work. Now, how do we proceed to create an encrypted cache? To create an encrypted cache, we'll use the WL encrypted cache.open. Now, this accepts three parameters. The first one is the credentials, which is the string value which represents the user provided password. The second is the create if none. Now, this is a Boolean value which specifies whether a new encrypted cache should be created in case none is found. Then thirdly, we have the onComplete callback function. Now, this is a callback function that's to be invoked when the cache opening or creating is complete. Then finally, there's the onError. Now, it's a callback function to be invoked when the cache is not successfully opened or created. The onError callback function is added after the onComplete. There are several statuses that can be retrieved from opening the encrypted cache. Now, this will tell you as to whether it was successful or an error occurred. We want to take a look at the several types of statuses that could result. The first one is the WL encrypted cache.OK. Now, this gives us a success message or a success signal that it was successfully opened and created or created. Then there's also the WL encrypted cache.error credentials mismatch. Now, this occurs when you submit a wrong credential when you try to open the cache. Then we also have the WL encrypted cache error secure random generator unavailable. Now, this means that the encrypted cache is unable to generate random token due to Worklight server unavailability. We also have the WL encrypted cache error no EOC. Now, this means that it could not open encrypted cache because it was not previously created. Then finally, we have the WL encrypted cache error local storage not supported to tell us if the device does not support HTML5 local storage. And then we have the error key creation in progress when the request is already running. Now, here's an example of how you would want to trap and process each of these errors. Here, there's a switch statement which captures all the cases or all the statuses and is processed based on which status results. Finally, when you have been able to create or open an encrypted cache, you would want to use it. And to use it would mean to read from the encrypted cache or to write data to the encrypted cache. Now, to write to the encrypted cache, we are going to use the WL encrypted cache.write function, providing the key, the value, the on-write success, and then the on-write failure callbacks. To read from the WL encrypted cache, we will use the WL encrypted cache.read. Here we also provide the key, the on-read success callback, and then the on-read failure callback. There are times where you would want to remove or close a cache. In a case where you want to remove data from a cache, we would use the encrypted cache.remove function to take away data from the cache. Here you pass in the key, the on-remove success callback, and then the on-remove failure callback. In a case where you want to close the cache, because we said it's like a deposit box, once it's opened, it remains opened. So if you want to close it, then you need to use the WL encrypted cache.close. Here you pass in the onClose complete handler and then the onClose failure handler callback functions. There are times where you would want to totally delete an encrypted cache. Worklight provides a mechanism to do that also. Here you are going to use the WL encrypted cache.destroy function. Here also you need to pass in a success handler callback and then a failure handler callback. Also, you might want to change the encryption key. Now, while the encrypted cache is in the open state, it's possible to change the encryption key. To do so, you would have to use the following API. You would use the WL encrypted cache.change credentials, passing in the new credentials, and then also a callback for when it's successful and then when it fails. Next, we want to talk about the JSON data store. Now, this is also another mechanism to store data. The JSON data store is a JavaScript API for data storage and manipulation. Now, this is based on the JavaScript object notation, JSON. Similar to local storage or the DOM storage, but with some advantages. It provides the following key features: storage of new and existing data that you can search, update, and delete without network connectivity. So you can search, update, and delete without having connection. There's also the ability to pull and push data to your back-end system. The encryption, there's also encryption for the stored data. Then there's enough tooling to get you started. Here is some comparison of the storage technologies. And now you can see that the JSONStore has a lot of these properties. It's supported in Android, iOS, web. It allows for data encryption. It has a higher maximum storage capacity. It can integrate adapters. It supports multiple users. And then it also supports indexing. comparing that to the other storage technologies, we can say that the JSON Store is superior. In JSON Store terminology, a document refers to a record or a row in a database terminology. So when we talk about documents, it's just like talking about a record or a row in a database. Now, this is a JavaScript object. So the example we see there, we see an underscore ID, which is the auto-generated identifier. And then we also see the JSON, which contains the data that is going to be stored. Then we also have what we call collection. Now, a collection is a logical grouping of related documents. Now, this is similar to a table in database terminology. We also have the search field. Now, this is a JavaScript object with a key and a data type. Keys are indexed for fast lookup times. Now, the use of this search field is that it helps us to determine how indexable fields are stored. So for example, if you define a field age as number, then it's indexed as 1, it's indexed as 1.0. And if you define an age as integer, then it indexes 1 as 1. There's also what we call the query. Now, it's a JavaScript object that uses search fields or other search fields to look for documents. Now, in the figure displayed, the search field is the string name. Now, when you query the collections for a name, and here for an example, we are using Beethoven, it identifies the document and then it returns that. So we have another example showing how we can use a search to retrieve a document. There's also the error object. Now, this is a JavaScript object that is returned when a JSON store operation fails. The error object provides information about the cause of failure. Now, not all the key value pairs are part of all error objects. So we can see an example of the error object. We see the source, we see error, we see message. It tells us, it gives us several details which we can use in debugging. We would want to now talk about the JSONStore architecture. Now, the diagram shown now shows the architecture of the JSON store. To retrieve data, the JSONStore API can speak to the Worklight adapter, and then the Worklight adapter will reach an enterprise system. Then, through the Worklight adapter, data is sent back to the JSONStore API, and then that is pushed into our internal storage. Sending data back through our JSONStore API, we are going to access the internal storage of our mobile device, fetch that data, return it back to the JSONStore JavaScript API, and that is going to push it through an adapter to the enterprise system. Now, the JSONStore API is only in JavaScript. You can use it when you develop Worklight hybrid applications, and you must wait for callbacks to get returns. To initialize a collection, we will use the init function. So we start a collection by means of creating a persistent storage that contains collections and documents if it does not exist. So the code snippet here is showing us how we can initialize a collection. Here the collection name is people. Now, after initializing a collection, to use it, we would need to retrieve it. And this is achieved by using the get function. So we use the get to create an accessor to the collection. We must call init before you call get. Otherwise, the result of get is undefined. Here's an example of how we will do that. So using the collection name of people, we would want to call on WL JSONStore.get, and we pass in the collection name. Now this is going to retrieve that collection for us and we can use it appropriately. To handle data locally using the JSON store, we have an API that we can use. The API provides functions that we can use to perform several things, including adding data, removing data, performing a count, doing a replace, searching, and storing data. All of these can be done using the JSONStore API. To add data, we are going to call on the .add and pass in the data and the options as required. Just like is shown in the slide, here our collection name is people. We have the data that we've initialized to the name Beethoven and an age of 57. So then when we call on WL JSONStore.get, passing in the collection name, we do a .add and then we pass in the data we want to add. Then finally there's the .then and there's the .fail. This one is for a success and a failure respectively. Now to do a find operation, we use find to locate a document inside a collection by using a query. So here also we would use the .find, we'll pass in the query, and then we would wait for the response. The .then when it's successful, and then the .failure when it fails. Our query here contains the column that we want to search. Here is name, and then what in particular, what value of name we want to search. Here is Beethoven. We can also do a replace by using a replace function to modify documents inside a collection. The field that you use to perform the replacement is the _ ID, which is the auto-generated ID. It's a unique identifier for every document. So here we will use the .replace, just like we use the .add, to now update a record or a document. Finally, if we want to take out a document from our collection, we would use the .remove to delete a document from that collection. Now, documents are not erased from the collection until you call a push. So even when you call the remove, you would need to call a push to erase it. Now, you can also use the remove collection function to delete all the documents that are stored inside a collection. This operation is similar to dropping a table in the database. Finally, you can destroy a JSON store. Now, this would remove all documents, collections, stores, and JSON store metadata and security artifacts. So in essence, you are wiping out all memory of your JSON store. We'll now proceed on to some JSON store advanced features. The first one we want to talk about is security. Now, we can secure all the collections in a store by giving a password to the init function. Now, if no password is given, the documents of all the collections in the store are not encrypted. So if you want them encrypted, then you need to provide a password. Some security metadata is also stored in the keychain in the iOS and in the shared preference on Android. The store is encrypted with a 256-bit AES. Now, this is very robust and secured. We would use this close all function to lock access to the collections until an init is called again. If you think of init as a login function, you can think of close all as the corresponding logout function. Finally, we can use change password to change password. Here is an example of how we would use a password on our collection. Here, the options variable or object is passed the password, and here our password is 123. So in creating or initializing our store, we pass that option to it. Then we handle when it's successful or when it fails. Another advanced feature of the JSON store is the multiple user support. Here we can create multiple stores that contain different collections in a single Worklight application. The init function can take an options object with a username. If no username is given, the default username is JSONStore. Here also is some code snippet showing us how that can be done. Another advanced feature is the adapter integration. Worklight adapter integration is optional and provides ways to send data from a collection to a Worklight adapter, get data from a Worklight adapter into a collection. One can achieve these goals by using the function such as WL-client, invoke procedure, or jQuery.ajax if more flexibility is needed. In the Worklight Studio, you can use the wizard to create a template JavaScript file. This creation is based on search fields that are selected from the back-end system that you use to communicate with the adapter. We now have some code snippets showing us how that can be achieved. We now move on to our final topic for today, which is pushing and pulling data with JSONStore. If an application is connected to an enterprise system by using an adapter, then we'll be able to push and pull data. Now with the API, you can push all or selected documents to the back-end system. You can also load data from the back-end system into the local store initially or refresh the local copy from the server. Local collection data is pushed or loaded by using a Worklight adapter. Calling the getPushRequired returns an array of what we call dirty documents. Now, these are documents which have the local modifications that do not exist on the enterprise system. These documents are sent to the Worklight adapter when push is called. Here's an example of how we would use the push. So by calling on WL-JSONStore.get.push, then we are pushing onto the server. This brings us to the end of today's session. The key areas which we covered today are encrypted cache, and then we also looked at the JSON data store. We continued to look at the JSONStore architecture and some advanced features. Finally, we looked at pushing and pulling data with JSONStore. Thank you.